Experiment number 38. Experimental determination of the distribution coefficient of ethanoic acid between water and 1-butanol. The aim of this experiment is to examine the dissolution and distribution of a solute in two immiscible liquids. Chemicals and equipments that are required to carry out this experiment are shown here. Burette stand, separating funnel holder, dropper, spatula, burette, pipette, conical flask, a beaker, white tile, measuring cylinder, sodium hydroxide solution, ethanoic acid, 1-butanol, distilled water, and phenolphthalein indicator. We will perform the experiment on mixture number 1 in the following table. To carry out this experiment, take a separating funnel and add 20 milliliters of 1-butanol. Next, add 10 milliliters of ethanoic acid. Finally, add 25 milliliters of distilled water. Shake the separating funnel to mix the contents well. Release the pressure that builds up in the separating funnel like this. Keep shaking the separating funnel for about 5 minutes. Using a separating funnel holder, stand the separating funnel for some time to allow the layers to separate. A layer separation can be observed. The top layer is the organic layer, whereas the bottom layer is the aqueous layer. Pipette out 10 milliliters of organic layer using a clean pipette into a conical flask. When pipetting out the organic layer, make sure that the tip of the pipette does not go into the bottom aqueous layer. Then add 10 milliliters of distilled water. We add distilled water to allow the titrant, which is ethanoic acid, to come into the aqueous phase. Add a few drops of phenolphthalein indicator. Take a burette and add sodium hydroxide up to the 0 mark of the burette. Titrate the solution with sodium hydroxide until a pale pink color appears. After the titration, note down the burette reading. Here, the burette reading is 7.9 milliliters. Next, we have to pipette out 10 milliliters of the aqueous phase. Using a clean pipette, transfer 10 milliliters of the aqueous phase into a conical flask. Add a few drops of phenolphthalein indicator. Titrate it with sodium hydroxide until a pale pink color appears. Note down the burette reading after the titration. Similarly, perform the second, third, fourth and the fifth experiments of the above table. The results of this experiment are shown in this slide. To calculate the distribution coefficient, we have to calculate the concentration of ethanoic acid in the organic layer and the aqueous layer. To do so, we have to make use of the results obtained from the titration. The reaction between ethanoic acid and sodium hydroxide is shown here. The volume of sodium hydroxide that was required to react with ethanoic acid in the organic layer is 7.9 milliliters. We can multiply the volume of sodium hydroxide by the concentration of sodium hydroxide to calculate the number of moles of sodium hydroxide. Since the molar ratio of sodium hydroxide is to ethanoic acid is 1:1, the number of moles of ethanoic acid will be equal to the number of moles of sodium hydroxide. Divide the number of moles of ethanoic acid by the volume of the organic layer to calculate the concentration of ethanoic acid in the organic layer. Similarly, calculate the concentration of ethanoic acid in the aqueous layer. Determine the distribution coefficient by dividing the concentration of ethanoic acid in the organic layer by the concentration of ethanoic acid in the aqueous layer. In a similar way, perform the calculation and determine the distribution coefficient for mixture number 2, 3, 4 and 5. The calculated results of distribution coefficient for each mixture is shown in this slide. It can be observed that the distribution coefficient is nearly equal in all the mixtures.